So let's now compare the tangent at the point P, the chord of contact at the point P, or polar of the point P. So now that we have discussed three of the cases individually for tangent, chord of contact and polar, now let's see the position of point connected with each of them in comparison. So let me make a tabular column of all these three connected with the point interior, point on and point exterior of the circle. So with the table which has the point P, x1, y1, which comes in the first row, and next is I have the tangent at P, which I take in my second column. So tangent at P and next is chord of contact at P, x1, y1, and next finally it is polar of the point P. So these are the three cases which I take for the point P, where the first case is interior point. If P is interior point of circle, and next is on the circle, and next is exterior point of the circle. Is how we have the three cases through which we understand the tangent, the chord of contact and the polar of P. So coming to the case 1, where tangent at P, say for example, if I take a point inside the circle, we know that a tangent is not possible. So no tangent, not possible, or does not exist. So the tangent does not exist if P lies inside, and if the point is on the circle, then we all know that we have a tangent at P, that is given by S1 equal to 0. So therefore, for a point on the circle, the tangent is S1 equal to 0. Now for exterior point, we cannot draw the tangent for any point outside, therefore does not exist. But of course you have pair of tangents which you can draw, but you cannot draw a tangent to the circle directly, and therefore the tangent does not exist for exterior point of circle. Similarly, chord of contact for a point inside the circle does not exist. And next, the chord of contact of a point on the circle is given by S1 equal to 0, and this is nothing but the tangent at P. The chord of contact and tangent are same at the point P, where we understand the chord of contact at P on the circle is nothing but tangent at that point x1, y1. Similarly, for an exterior point of circle, the chord of contact is given by S1 equal to 0. That is, when I take an exterior point P, I can draw two tangents where this is the chord of contact given by S1 equal to 0. Next, polar of P for a point interior of circle. So when I take a point interior of circle, then the polar is given by S1 equal to 0, and that is with the limitation which we have taken that P is assumed as not the center of circle. That is, P is any point inside the circle but cannot be the center of circle. Except the center of circle, P is assumed to be any point on the circle. Next, polar of P on the circle is given by S1 equal to 0, and this is nothing but part of tangent. We all know it is the unique point P through which all the chords pass, and hence the polar of P for a point on the circle is nothing but part of tangent or coincides with the tangent. Similarly, the polar of P for an exterior point we have seen in the previous case is nothing but the chord of contact. That is, it is given by the formula S1 equal to 0, but the polar of a point outside the circle is nothing but chord of contact at P. Is how I understand the three cases for a tangent, the chord of contact, and the polar of a point with respect to the circle S equal to 0. Now next, we'll see how to find the pole. Now finding the pole is one of the important concepts, because finding the polar is obviously done by using the formula S1 equal to 0, which is by direct substitution of the point into the circle using S1 equal to 0. But what in the reverse process if I give the polar and then I want to find the pole for the circle? So let's see how I can use the reverse process in finding the pole when a polar is already given out there. So in this case, the question is, find the pole of x plus y plus 2 equal to 0 with respect to the circle x squared plus y squared minus 4x plus 6y minus 12 equals 0. So here the question is about finding the pole for this line, which is the polar with respect to the circle x squared plus y squared minus 4x plus 6y minus 12 equal to 0. So let's see the process of finding the pole. Now initially the circle given out here is x squared plus y squared minus 4x plus 6y minus 12 equal to 0. Now for this circle I have, say, let P x1 y1 be the pole. So assuming that the point P x1 y1 is the pole, so in order that I need to find the pole, I need to find the values of x1 and y1. Is how I understand finding of the pole. So let P x1 y1 be the pole. It implies polar of P is given to be x plus y plus 2 equals 0 is what I take equation 1. Now polar of P is already given to be the line x plus y plus 2 equal to 0. Now, but we have the formula where polar of P x1 y1 with respect to the circle S equal to 0 is S1 equal to 0. We already know that the formula is when P is the pole, then polar of P x1 y1 with respect to the circle S equal to 0 is S1 equal to 0. That is, my S1, which is x1 plus y1 minus half of 4, which is 2, times x plus x1, and half of 6, which is 3, plus 3 times y plus y1 minus 2l equals 0. So this I want to simplify in the form of x and y, where this x term and this x term are taken common, so that x1 minus 2 of x, this can be simplified as x1 minus 2 of x plus y1 plus 3 of y plus I have next minus 2x1 plus 3y1 minus 2x1 plus 3y1 minus 2l equals 0 is how I get the polar of px1 y1 with respect to the circle. So this is equation 2 which I take. So using this, I see that this is the polar of the given line through which I find x1 y1. Now that we have obtained this line through using the pole p x1 y1, I understand that equation 2 is polar of p x1 y1 with respect to the circle S equal to 0. So equation 2 is identified to be the polar of p x1 y1 with respect to S equal to 0. But one is already given to be the polar of the circle, is already the polar of p with respect to S equal to 0. So this makes me understand that 1 and 2 represent the same line, because this is the polar of the circle and this also is the polar which we found using the formula for the circle. That implies 1 and 2 represent the same line, is how we understand. Now when these two represent same line, their coefficients must be in same proportion. That is, if these two are same lines, then this divided by this, that is coefficient of this, must be in same proportion with coefficient of y by 1, and that by 2 is how we understand in same proportion. Now continuing from here, I first simplified these two equations which give me x1 minus 2 equals y1 plus 3. That is x1 minus y1 is 2 plus 3, which is 5, which I take as equation 3. Now I take the next two equations, that is this and this, which gives me one more equation. Ultimately, the concept here is to use the elimination method in solving two unknowns x1 and y1. So here I take from the first and last, I have 2 times of x1 minus 2 is 1 times of minus 2x1 plus 3y1 minus 2l, which on simplification gives 2x1 minus 4 is this minus this, which on further simplification gives 4x1 minus 3y1 is equal to 4 minus 2l, which is minus 8. So 4x1 minus 3y1 is minus 8, which I take as equation 4. Now it is very essential that I simplify for equation 3 and 4 for finding x and y, or x1 and y1. So I take equation 4 multiplied with 3, so that this becomes 3x1 minus 3y1 equals 15, and this is the direct equation which I take. 4x1 minus 3y1 is this, which on subtraction cancels this, and this gives me minus x1 is 15 plus 8 is 23. That implies x1 is negative 23, which on substitution in y1 gives me, so when I substitute in this, I get y1 equals x1 minus 5, that is minus 23 minus 5, which is minus 28. Therefore, I have 2 points. X1 is minus 23 and y1 is minus 28. Therefore, I get my x1 to be minus 23 and my y1, which is minus 23 minus 5, which is minus 28, and y1 is minus 28. Therefore, the point P x1 y1 reduces to P x1 y1, which is the pole. Therefore, the pole of the line x plus y plus 2 with respect to circle is minus 23 and minus 28. This is how we find the pole using the formula connected with proportion, ratios and proportion. Finding the pole for the circle S equal to 0. So let's see through a realistic diagram out there. So if I have a circle and I take an external point P, say x1 y1, then I want to draw the polar for this point, then in that case I take a line passing through this, which cuts at say P1 and P2. So P1 and P2 are the corresponding points for pole Px1 y1. So here I get the chord of contact when I intersect these two, and I get the locus of tangents which intersect here. That is, I get this, which is polar of P. So this is the polar of P. Now the geometrical property which is very interesting out here is that if I take a point on polar of P, suppose I take a point say Q, which is x2 y2, then this point is very much connected with this point, which says that if the polar of P is this line, then if Q x2 y2 lies on polar of P, then we have the polar of Q where P x1 y1 lies. That is, polar P lies on polar of Q and Q lies on polar of P. To say in the most simple words, they lie on each other of their polars. So Q lies on polar of P. Now this P must lie on polar of Q. That means this line must be the polar for Q. That is, if I just take this point of intersection, then from here, if I draw the pair of tangents, this being the chord of contact, then I have the two lines which must pass to the point P. So if I take this Q1 and Q2, they must pass through P. That is, polar of P x1 y1 passes through Q x2 y2 if and only if polar of Q x2 y2 passes through P x1 y1. Is how we understand through the diagram. So polar of P passes through Q implies the polar of Q passes through P x1 y1 is how we understand the concept. Now in the previous case we have seen one of the interesting geometrical concept which we are going to recap. That is, we have seen that if I have a circle S equal to 0, then if I have a point P x1 y1 outside the circle, then I get the polar then here we know that we get the pair of tangents which gives me the polar of P through which I have the point Q which I take on polar of P. Then this is said to pass through P, which is said to be polar of Q. So polar of P is here and polar of Q is here. That means we have seen that if P is a point outside the circle or anywhere inside or on, then if the polar of P has Q as its point, then the polar of Q will have P as its point, is how we understand. So in this case, these 2 points are said to be conjugate points. If one lies on the other polar and one lies simultaneously in the other polar, we say that the 2 points are conjugate points. So here we have the case that P x1 y1 and Q x2 y2 are called the conjugate points, is how we understand the conjugate points connected with the circle. Now let's see the condition for existence of 2 points to be conjugate. So conjugate points with their condition. So P x1 y1 and Q x2 y2 are said to be the conjugate points for the circle S equal to 0 if S12 is equal to 0 is the condition for conjugate points. If S12 is equal to 0, we say the 2 points are conjugate points. That is, if x1 x2 plus y1 y2 plus g plus f is equal to 0 is the condition for conjugate points of a general circle S equal to 0. Is how we understand the condition for conjugate points. Now next comes conjugate lines. Now that we have discussed or defined about conjugate points, in similar fashion we define the conjugate lines. So let's recap with the conjugate points in order to understand the conjugate lines connected with the conjugate points. Say I have a circle and I have a point P x1 y1 through which I draw the pair of tangents which gives me the polar of P. Now say there is point Q x2 y2 through which I draw the pair of tangents out here. So P and Q are the 2 points, that is, they are the conjugate points because polar of P, Q lies on polar of P and P lies on polar of Q. Therefore, these 2 points are conjugate points. And the lines involved in the conjugate points are called conjugate lines. That is, the polar of Q and the polar of P are said to be the conjugate lines. In this case, this and this are said to be the conjugate lines. So therefore, L1 or L2 which I take are conjugate lines which have the conjugate points on them of respective polars of each other. That's how we understand the conjugate lines connected with conjugate points.